Systems of equations with quadratics. Okay, we did systems of equations back in concept 5, and we're going to do them again today with quadratics and linear equations. So, first of all, a solution to a system is a point. So anytime you write your answer, you need to make sure it's in a point, x comma y. And I have a couple of graphing reminders here. If we have standard form, so if it's in ax squared plus bx plus c equals 0, you're going to use negative b over 2a to find your vertex. If it is in intercept form, so x plus p, or x minus p and x minus q, you're going to use p plus q over 2 to find your vertex. And we're going to also be using x, y tables to find points. Okay, so first of all, we need to talk about the number of solutions. If we graph one quadratic and one linear equation, we can have 0, 1, or 2 solutions. So 0 solutions, they wouldn't cross at all. 1 solution, they would touch once. Or 2 solutions, they would cross twice. Okay, so we're going to start by solving by graphing. So we're going to graph both these equations and see where they cross. I'm going to start with the linear equation. So with the linear equation, our y-intercept is negative 2, so I'll put a dot at negative 2. And then our slope is 1, so that's 1 over 1. So we're going to go up 1 and over 1 in both directions. Okay, and then for my quadratic equation, it's currently in standard form, so I'm going to use negative b over 2a to help me find the x-coordinate of my vertex. So negative b would be a negative 4, which is positive, over 2 times a, which is 1. So my vertex is going to be the point 2, comma, and in order to find the y-coordinate of my vertex, I need to plug 2 back into my equation. So 2 squared minus 4 times 2 minus 2. If I plug that in my calculator, I get out negative 6. Okay, so my vertex is at 2, negative 6. Now, to get the rest of the points, I just need to fill out an xy table. So I'll put my vertex in the middle, and then maybe we'll plug in 1, 0, and maybe even negative 1, 3, 4, and 5. Okay, if we plug 1 into our equation, so 1 squared minus 4 times 1 minus 2, we're going to get out negative 5. And since quadratics are symmetric, I also know that if I were to plug in 3, I would get out negative 5. Since I've placed the vertex here, I know I can do this each time with my y value. Now if I plug in 0, 0 squared minus 4 times 0 minus 2 is just going to be negative 2. Same thing for plugging in 4. And then my last one, if I plug in negative 1, so negative 1 squared minus 4 times negative 1 minus 2, I will get out 3. Okay, so now if I plot all of these, let's see, we'll start with 1, negative 5, and then 0, negative 2, and negative 1, 3. Okay, and I know I can stop here because I see that I have 2 solutions to my quadratic, and I know I can't have more than that, so I know those 2 must be my answers. So my final answers here are the points 0, negative 2, and 5, 3. Next, we're going to solve by substitution. So if you recall in substitution, we need to solve for a letter in one of our 2 equations and then plug what's equal to that letter into the other equation. So on this bottom equation, as you can see, I have y solved for. Y equals negative 3x minus 3. So I'm just going to take negative 3x minus 3 and I'm going to plug it into where y is in my top equation. So I just rewrote the top equation, but instead of y, I put negative 3x minus 3. Okay, and so I now need to get everything on the same side, and then I will be solving a quadratic. So since I'm going to solve this quadratic algebraically, keep in mind you always want your x squared to be positive. So I'm going to move everything to the right side. So I'm going to subtract my 2x over, and add my 3 over. If I put this in standard form, I'll want my x squared first, and negative 3 and 3 cancel out. Okay, so now I have a quadratic to solve, and this is actually in a nice form. All I'm going to have to do is pull a GCF out because I have an x squared and an x term. So 5x squared divided by 5x, I'll just have 1x left, and negative 5x divided by 5x, I'll have a negative 1. So now I'm going to set both parts of these equal to 0 and solve. So my answers are x equals 1 and x equals 0. But keep in mind, we always have to have points, so I need to find the y-coordinates of these 2 points. I can plug my 0 into either the top or the bottom equation, the original equations, and I'm going to choose the bottom equation for this because that looks easiest. So if I do negative 3 times 0 minus 3, I'm just going to get a negative 3. Okay, so now if I plug 1 into that same equation, negative 3 times 1 is negative 3, minus 3 is a negative 6. So my solutions are 0, negative 3, and 1, negative 6. Okay, next we're going to solve this by elimination. So in order to solve by elimination, I need to get like terms in the same column. So I already have my 2 constants in the same column. It's just my x's and my y's that I need to flip. So I'm going to rewrite the first problem. I'm going to leave it the same. The second problem I'm going to rewrite. I'm sorry, that should have been a positive one. The second problem I'm going to rewrite, and I'm going to switch my x and my y. I left them both positive. Okay, so now I can just eliminate a variable from this. My y's are already opposites, so I'm just going to add down and eliminate my y's. Dividing both sides by 3, I'm going to get x squared equals 0. Now I need to take the square roots of both sides. I get x equals 0. Earlier we talked about how there needed to be a plus or minus if you're solving a quadratic equation this way, but a plus and a minus 0 doesn't make sense. So your answer here is just 0. Now we need to write these two as, this is points, so we have 0, comma. We just need to plug 0 back in for x in one of our 2 equations. If I pick that bottom equation, this 2 times 0 squared term cancels out, and I'm just left with y equals negative 1. And there's my solution.